In this problem, we're going to go over a combustion reaction. So we're told that we have a 1 gram sample of a hydrocarbon. We combust it and obtain 0.692 grams of water and 3.381 grams of carbon dioxide. Part A, we want to determine the masses of carbon and hydrogen in the initial hydrocarbon. So part A, let's start with CO2 and carbon, since that's a little bit simpler. So we're told we have 3.381 grams of CO2. Let's convert that to moles of CO2. And in every 1 mole of CO2, we have 44.01 grams of CO2. That's from adding up the different elements on the periodic table to get the molar mass of CO2. And then we want to go from moles of CO2 to moles of carbon. But we have a 1-to-1 ratio there because 1 mole of CO2 contains 1 mole of carbon. Then we want to get rid of moles carbon. So we use the molar mass of carbon atoms. That's 12.01 grams of carbon atoms in 1 mole of carbon. And that gives us 0.9226 grams of carbon. Now let's do water and hydrogen. So we have 0.692 grams of water. Let's convert that to moles of water. So 1 mole of water is equal to 18.015 grams of water. And we want to go from moles of water to moles of hydrogen atoms. And here we have a 2-to-1 ratio because 1 mole of water contains 2 moles of hydrogen. And then we go from moles of hydrogen to grams of hydrogen using the molar mass from the periodic table. And plugging that into our calculator, we get 0.0774 grams of hydrogen. So our masses of carbon and hydrogen in the hydrocarbon, we found we have 0.9226 grams of carbon and 0.0774 grams of hydrogen. Part B, are any elements missing? So we can figure that out if by adding up the weights of carbon, the masses of carbon and hydrogen, if that does not equal 1.00 grams, then we know that something is missing and it isn't just a pure hydrocarbon made of carbon and hydrogen. So let's find out. So we have 0.9226 grams of carbon plus 0.0774 grams of hydrogen. And we can pretty easily see or plug it into our calculator that that does in fact equal 1.000 grams. So our entire 1 gram sample is accounted for by the masses of carbon and hydrogen. So we can say that no elements are missing. Our hydrocarbon is just carbon and hydrogen. Part C, we want the mass percentages of carbon and hydrogen. And our general formula for mass percentage is the mass of one component over the mass total for the compound multiplied by 100% to move it from a decimal form to a percent form. And so our mass percentages are easy to calculate because we have our mass of carbon and our mass of hydrogen, and we divide each of those by 1 gram because that is the total mass of the sample. So our percent carbon is equal to 0.9226 divided by 1, our 1 gram sample. that gives us our same 0.9226. Multiplied by 100%, we find that our mass percentage for carbon is 92.26% carbon by mass, and our percent hydrogen is equal to our mass contributed by hydrogen in the compound divided by our total mass, which is 1 gram, multiplied by 100%, we get, and multiplying by 100% is the same as moving this decimal point over 2 places. Because if you think about it, we're multiplying by 100, so we're making this small number larger by 2 factors of 10, which is 2 decimal places. So that gives us 7.74% hydrogen. So our mass percentages for C and H, 92.26% carbon and 7.74% hydrogen. Part D, we want to get our empirical formula of the hydrocarbon. And so the empirical formula is all about ratios of elements in the compound. Our compound only contains carbon and hydrogen, so our empirical formula will be some ratio of carbon to hydrogen. And so to determine that, we need to know the number of moles of carbon and hydrogen in this hydrocarbon. We have the masses from part A, so we're going to convert the masses in part A to moles, and then compare the number of moles of carbon and hydrogen and see what that ratio is so that we can replace these subscripts with numbers. So we have 0.9226 grams of carbon. We want to use the molar mass, 12.01 grams of carbon, to convert that to moles of carbon. And that's equal to 0.0768 moles of carbon. We want to do the same thing with hydrogen, 0.0774 grams of hydrogen. 1 mole of hydrogen has 1.0079 grams of hydrogen. Of course, our units are canceling, leaving us with moles hydrogen, and that gives us a value of 0.0768 moles of hydrogen. And so if we compare these two values, we see that they are identical, which means that the ratio of carbon to hydrogen in our hydrocarbon is 1 to 1. Because if we divide this number of moles of carbon by this number of moles of hydrogen, we get a value of 1. If we had twice as many moles of carbon as hydrogen, we would get a value of 2. So our empirical formula for the hydrocarbon is simply CH.